welcome to Mindset Learn Extra Live. This is grade 11 maths. Today we're doing algebra. Hey, Natasha.
Yes, guys, and you're not seeing double and you didn't tune in at the wrong time. I am taking the grade 11 show as well, and we're going to be looking at algebra revision.
Yes, we're excited to have you back again for grade 11s. I know the grade 11s are keen for revision because it is exam time very soon, so revision is very critical. Remember that you can ask any questions that you want, anything on facebook.com/learn extra and on Twitter at Learn Extra. That's the one. I know you guys know it better than I do as well. Remember, guys, our show is sponsored by Liberty. Thank you very much, Liberty. And also, other exciting news. Grade 11s, we don't forget about you. We also have a Casio calculator to give away to the lucky mindsetter, as well as the labeler. Ask Noxie. She loves her labeler. Thank you very much for the photo that she sent us as well. Guys, enjoy your show. Natasha, over to you.
Thank you, Katleho. Guys, welcome back once again to the show, and we've got lots to cover today in grade 11. You know that it's almost time for the exams. You can especially feel it because it's getting quite cold outside. And there's nothing better to do when it's cold outside than to stay inside with some books. So today we're going to look at the revision of algebra. We're going to go over everything very briefly that we've done so far in the last few weeks. All right, just to remind you guys, some of the sections we have covered in algebra, obviously we're not going to be able to get through every single question in this 1 hour session, but some of the things we have looked at are number patterns, completing the square, quadratic equations, inequalities, simultaneous equations, and then the very, very big one was functions. We did that for a few weeks. All right, so we're going to do a nice big question on functions. So guys, now is the perfect time if you have questions on algebra, really any section of algebra at all. Now's the time to ask Katleho on the Facebook page. All right, so we're going to look at some exam type questions. The first one we're going to look at deals with number patterns. All right, and the question says, a researcher is investigating the number of trees in a forest over a period of n years. After investigating numerous data, the following data model emerged. All right, and then they give you a little table, and you see that in year 1, the number of trees, and remember, important here, this is in hundreds. So in year 1, there was 100 trees. Then in year 2, 300 trees. Year 3, 900 trees. And then in year 4, 2,700 trees. Okay, remember we're timesing by 100 each time because this column is given to you in hundreds. All right, so typical exam question. The first one says, how many trees in hundreds are there? Whoopsie, are there? Let's just undo that before we make a bit of a mess. There we go. How many trees in hundreds are there in the 6th year? Okay, so they tell you the time that you're looking at if this pattern is continued. All right, so that means that there must be some pattern that we need to discover. All right, so let's have a look at the table, guys, and let's see what this pattern is. If you look at year 1, you've got 100 trees. All right, let's just, for the time being and for the sake of simplicity, we're going to leave it as 1, 3, 9, and 27. When we use these hundreds to explain, it gets a little bit tricky for us. So in year 1, we have 1 tree. In year 2, we have 3. Is there a pattern that you can see? And hopefully you guys at home can see that in year 1, and we can see that with the rest of these as well, it seems to be some sort of factor or some sort of multiple, of 3. So in year 1, we can rewrite 1 tree as 3 to the power of 0, because 3 to the power of 0 is equal to 1. In year 2, when there are 3 trees, we can write that as 3 to the power of 1. All right. In year 3, we have 9 trees. We can rewrite that as 3 squared. And in year 4, we have 27 trees, which is 3 cubed. All right, so hopefully you guys can see a pattern emerging here. In year 1, we raise 3 to the power of 1 less than 1. So 1 minus 1 is 3 to the power of 0. In year 2, we do the same thing. 3 to the power of 1, which is just 2 minus 1. Why am I using 2? Because that's the year we're referring to. So in year 2, I don't have 3 squared number of trees. I have 3 to the power of 2 minus 1. So it's always 1 less than the year that we are in. All right. So in year 3, we go 3 squared, which is 3 to the power of 1 less than what we're looking at. And in year 4, similarly, 3 to the power of 4, 1 less. So therefore, if this pattern continues, in the 6th year, right, we're going to go and have a look at the forest, and we'll see there's going to be 3 to the power of 6 minus 1 trees. So that's going to give me 3 to the power of 5. All right, and what is 3 to the power of 5? That's going to be 243. All right, so guys, hopefully you follow that. So how did I get 243? All I did is I continued this pattern that we have. We say it's going to be 3 to the power of 1 less than the year we're in to get the number of trees in that specific year. So in year 6, it's going to be 3 to the power of 5, which is 240 trees, but that's not the correct final answer because remember they wanted the answer in hundreds. So therefore we need to times this by 100. And we get 24,300. So therefore, in year 6, there's 24,300 trees. All right. Okay, so let's go over that just one more time on this table. Remember, we were given the year, we were given the number of trees, and all we saw in the pattern is that if I wanted to work out the number of trees, I had to raise 3 to 1 less power than the year we were in. So in year 1, I raised 3 to the power of 0. In year 2, 3 to the power of 1, and so on and so on and so on. All right. The next question says, determine an algebraic expression that describes the number of trees in the nth year. Okay. Remember, the nth year is really just meaning at any point in time, if I wanted to find out the number of trees, what formula would I use? So we don't know which year we're in, but at any point in time, what is the formula we would use? And we saw from what we worked out before that it's 3 to the power of the year that we're in, which we're going to call n, minus 1. All right, and this makes sense, guys. If you test it out with your formula, 3 to the power of n minus 1. Let's go back here. If that is my formula in the nth year for the number of trees, if I wanted the number of trees in year 1, I'm going to say 3 to the power of 1 minus 1, which gives me 3 to the 0, which is just 1. If I wanted the number of trees in year 3, I'd go 3 to the power of 3 minus 1, which is 3 squared, and that's 9. All right, so you can see that those answers are correct, and they do correspond with the table that you've been given. All right, so finally, they say, do you think this model, okay, where every tree, if we want to find the number of trees, it's 3 to the power of n minus 1, do you think this model, which determines the number of trees in the forest, will continue indefinitely, and give a reason for your answer? So remember, indefinitely means forever and forever and forever. So do you think that this pattern can continue forever? Now you've got to think about it logically. And I mean, this happens in real life out there, the forestry departments and that kind of thing. They monitor the number of trees in a specific forest. So this number n can become extremely large. I mean, you can think about it in 100 years, in 1,000 years, and so on and so on and so on. So this n can become very large. So it can be infinite, really. It can be a huge number, which means the number of trees that you have can be infinite. It's going to be a massive number of trees. And so the forestry departments will not allow this to just continue unabated All right, they will not allow the trees to just grow and grow and grow and grow. At some point, they will step in and cut down some of the trees just to maintain the ecosystem and the balance. Remember, everything in nature has a balance and everything follows a certain pattern. And so if they see that the trees are multiplying at such a rapid rate, they will step in and cut some of them down. So no, this pattern will not continue indefinitely, just simply because mankind will step in and make sure that there's a balance restored once again. All right, so that was our first question for the evening on number patterns. If you have any questions on number patterns, please send those questions through to Katleho on the Facebook page, and we will get to those by the end of the show. Katleho, back to you.
That's true, guys. Remember, I'm waiting for all your questions and queries. Remember also that there's a challenge question up, so you can answer that all throughout the show. And in the last 15 minutes, we'll be going through it nicely and slowly and checking who are the buffs out there that did it first. See you after the break. Welcome back, Mindsetters, from a very, very quick break. Hope you guys are ready for another segment of an exciting show, Grade 11s. I hear on the page that you guys are excited for the revision. And I know from my Grade 11 as well, it was very nice to have some revision to go through before exams, so you're not so stressed and clogged up with all your work and whatever. And if you have questions, this is the right time to ask them so that we can go through everything you don't understand on algebra. Was that fine with you? Perfect. Over to you, Natasha.
Thank you, Katleho. Guys, welcome back to the show. As Katleho said, we're doing a lot of revision today, and we've started off looking at number patterns. Remember, there's so much you can do in number patterns. We looked specifically at a series where we had to take the number 3 and raise it to a power, but there's also quadratic number patterns, and there's all sorts of number patterns. So if you have any question like that, please send it through to us and we will try and help you. But for now, we're going to move on to the next area of revision, which is solving for x by completing the square. And this is one that I know sometimes becomes quite a mess. Okay, I've seen students make quite a mess of this kind of question. They say solve for x by completing the square, and incidentally, guys, this is your challenge question. All right, so hopefully some of you will get the answer to Katleho before we get to the end of this little segment where I give you the answer. All right, so this was our challenge question. Solve for x by completing the square, and we had x squared minus px minus 4. All right, and then we're going to go over this one as well, which I've added in. X squared minus 3x minus 4. We're going to try and do that one as well. All right, but for your challenge question, x squared minus px minus 4, first step is to isolate your x and take your number, your 4, your constant term, to the right-hand side. Okay, you only want x's on the left-hand side. Okay, once you've got it in this form, we're then going to divide through by the coefficient of x squared. Now here the coefficient of x squared is just 1. So if I divide everything by 1, it's not going to change anything. All right, so my sum is going to stay exactly the same. Next step, and completing the square, guys, really it is all about just remembering steps. You follow steps, you learn it off by heart, there's a pattern, and you keep using the same pattern. It doesn't change, all right? The difference here is when we're solving for x by completing the square, the difference here compared to if you're completing the square to find the turning point in a parabola, the difference is you're not going to take things across this equality sign. Okay, when you try to complete the square to find the turning point, you keep everything in the equation. There's no dividing through and dividing numbers out and that kind of thing, because it's not an equation. Okay, so there's no equality sign when you're trying to find your turning point. Whereas for completing the square with equations, you can divide numbers out. So I could divide the coefficient of 1 out of the sum. All right. So the next thing we're going to do is we're going to then find a half of the b term. So this step is an important step and stays the same whether you either completing the square to find the turning point or solving for x. We find a half of the b term and we add it squared to both sides. So a half of p is going to be p over 2, and we add that squared to the left-hand side, and we add that squared to the right-hand side. All right, so we add a half of the b term, a half of p is p over 2. We add it squared to both sides. The reason we do this in an equation where we add the same value on both sides is, remember, in an equation you're always trying to balance things out. So if I do something to the left-hand side, I need to do it to the right-hand side. So remember, this p over 2 squared, it wasn't originally in the sum. I put it in. So therefore, I need to negate that effect. I need to take it out of the sum by adding it on the right-hand side as well. So whatever you do to one side, you have to do to the other side of the equation. All right. So we've done that part. The next step is factorize the left-hand side. So if I factorize this, I'm going to get x. Keep the sign of the middle term, so it's going to be minus. And the term that we're going to put in here, let's just get rid of that bracket. So I'm going to have x minus. The term we're going to put here is really just the term that's inside this bracket squared. So it's going to be x minus p over 2, which is a half of our b term squared. So if we had to factorize x squared minus px plus p over 2 squared, we will get x minus p over 2 squared. Guys, this is a step that sometimes confuses everyone. We're really just factorizing the trinomial. If you are confused about how to factorize trinomials and that kind of thing, once again, you need to go back and you need to revise those early sections that you did. All right, maybe even go back as far as grade 10, just revise trinomials. It is an important section. All right, so we're going to factorize the left-hand side and simplify the right-hand side. So I get 4 plus, square the bracket out, p squared over 4. All right, and I'm going to simplify that a little bit more. So I'm going to get an LCD here of 4 times through by my LCD, so find a common denominator of 4, and then we're going to add our terms together, so that means I need to times the 4 over 1 by 4 over 4, so I get 16 plus p squared all over 4. So all I did here, I found an LCD and added my fractions, and I've got x minus p over 2 squared is 16 plus p squared over 4. Now remember, we are solving for x, so we need to get rid of that square by square rooting both sides. So I'll get x minus p over 2 is equal to the square root of that entire expression. And hopefully we've got some answers already on the page.
We've got plenty of answers.
What did they get, Katleho?
I wish you'd see this so that you can actually interpret it. Everyone's written it in a fairly different way.
Okay, so I'll come over there just now and have a look. Let's just finish this sum off. So we've got the root of 16 plus p squared all over 4. So we're going to split this root up into 16 plus p squared. We can't square root anything in the numerator, but we can square root the denominator. The square root of 4 is 2. And then we're simply going to take this p over 2 to the right-hand side. But very, very important thing to remember is when you take the square root of any number is always plus or minus. Okay, so therefore we must put our plus and minus sign in there. We're going to take the p over 2 over, so we're going to get p over 2 plus or minus the root of 16 plus p squared all over 2. And since they have the same denominator, I can write it all on one line. So it's p plus or minus the root of 16 plus p squared all over 2. Okay, do any of the answers look anything like that?
All over 2. Yes, I do. Zwanaka Naki Poya's answer does look exactly like that. So she got it right, yes.
All right, good. Well done. What was her name again?
Zwanaka.
Zwanaka. Well done, Zwanaka. Was she the first one to get it right?
Yes, she was the first person to get
excellent,
it right.
Excellent work. This is a
tricky
question.
Also Tapoloho also got it right.
Okay, well, I'm well impressed, guys. That's good work. That's amazing. Yeah. So this is, as I was saying, this is a tricky question because people see letters and straight away they fly into panic mode. And there really is nothing to panic about because if you know the steps, you're just going to apply the same steps that you learned. Apply it to the letters. So don't let the letters scare you. All right. Do I need to come over there and congratulate any more people? Or
Yes,
let's have a look.
actually.
All right.
So here's Tapulocho's one, Zonaka's one. These ones. And
Wow, okay, so a lot of you guys have got it right, and I think it is quite difficult to write it, in text format and send it through on our Facebook page. So I'm very impressed that some of you managed to actually do it and write it out nicely. And we had Khosatso, I think it is, saying, yo, it's hard. I have to agree, it is a hard one, but well done. And hopefully, Khosatso, and I'm sure I'm saying that wrong, hopefully you followed and hopefully you understand it now.
And if you don't understand anything, remember that you can still ask us questions on this. So when the show ends, you understand it and you can do it all by yourself.
All right. So guys, we're going to look at another question of this very, very similar. In fact, all I've done, it's actually exactly the same question. All I've done is I've replaced the P with a 3. That's really all I've done. Otherwise, it's exactly the same question. Just to show you that you shouldn't be scared by letters. All right, because remember, letters are just a placeholder for numbers. They're exactly the same process you will apply. So, let's see if any of you can get this answer over to Katleho. The question is x squared minus 3x minus 4, and I want you to solve by completing the square. So I want to know what are the answers going to be of x squared minus 3x minus 4. Let's see if you can get to it before we do it. All right. So guys, as I said, it's exactly the same process, except for now, in place of that letter, we have a number. So it's x squared minus 3x minus 4. We do the same steps. Isolate the variables and take the 4 to the right-hand side. So we end up with x squared minus 3x equaling 4. Then we find a half of the b term and we add it squared to both sides. All right, here remember, once again, you'll divide through by the coefficient of x squared, but because it's just a 1, we're not going to change anything in the sum. So it's x squared minus 3x plus a half of 3 is just going to be 3 over 2, all squared, is equal to 4 plus 3 over 2, all squared. All right, and now we're going to factorize the left-hand side, so we get x minus 3 over 2 all squared is equal to 4 plus 9 over 4. Okay, now guys, if I just show you from this step, let's just go back to the one with the p. And you'll see here we've got x minus 3 over 2 squared is equal to 4 plus 9 over 4. Almost identical with the p. It's just, obviously, we had p's instead of the 3. So you see we got x minus p over 2 squared. Now we've got x minus 3 over 2 squared is equal to 4 plus p squared over 4. And now we've just got, instead of p squared, we've got 9 over 4. So it really is exactly the same thing, and no need to get scared by the letters. All right, so we're going to simplify. Our LCD here is 4. So we times through by a common denominator. It's going to become 16 plus 9. And 16 plus 9 is 25 all over 4. And then we want to get rid of the square, so therefore we square root both sides and we'd get x minus 3 over 2 is equal to plus or minus. The square root of 25 is 5, and the square root of 4 is 2. So, taking my 3 over 2 over, I'll get x is equal to 3 over 2 plus or minus 5 over 2. Okay, now we can split this up. It's either going to be 3 over 2 plus 5 over 2, or 3 over 2 minus 5 over 2. 3 plus 5 is going to give me 8 over 2 is just going to give me 4. Or 3 minus 5 is going to give me minus 2 all over 2, which is minus 1. So our answers here are 4 and minus 1. And in fact, you actually could have factorized the sum straight from the beginning and got those as your answers. But just by completing the square, you can see that you get exactly the same answer. So if you took that trinomial and factorized it and solved for x, you would have got the same answers, 4 or minus 1. And incidentally, the reason this works out the way it does is because, remember that formula that you learned? This formula here, x equals minus b plus minus root b squared minus 4ac. A lot of you use this to solve equations, all over 2a. That formula comes and is derived from completing the square. So this formula really, all they did is they took an expression ax squared plus bx plus c, which is any quadratic expression in standard form. They simplified that and they got down to this formula, which you now all use to help you to factorize and to solve for x. All right. So yeah, so that's why those answers work out to be exactly the same as if you were to just factorize it and solve for x by yourself. Okay. Because it all comes from completing the square. So, has anyone got those two answers?
Not yet. I think that one you went through too fast. Maybe they're still trying to get through that.
All right. Okay. So I think we're going to take a little break.
Yeah. Hey, let's do that. Maybe it gives you guys more time to even check what you don't understand, because now you know the answer. Now you can go through your answer and maybe just compare them and see what you can come up with. See you after the break. Welcome back, guys, from that quick break. Hope you guys are really enjoying the show and on the ball. I can see all the questions are being answered by you guys, and you guys are helping each other, as well as sending in all your answers to all the questions that Natasha gave you. Well done, guys. This is fantastic. I mean, we're enjoying it so much, and there's so much action on the page as well, which makes it that much more exciting. Hey, Natasha.
Yes, absolutely. Now, Kudlehu, you were saying to me that someone had a question about the challenge question, and will you just repeat the question for all of our viewers?
They asked why you used p and not minus p
in completing the square. Okay, so the question is, in this example we gave you, x squared minus px plus 4, why didn't I put in minus p over 2 in this bracket? And not even theoretically, practically, that is correct. You're supposed to actually put in the minus with the p in the bracket. The reason I didn't do it, and I always leave it out, simply because if you square it out, if you square a minus, it's going to end up being positive. So it doesn't really matter. So the sign is sort of irrelevant. But for complete correctness, you are absolutely right. You are supposed to put that minus into the bracket. But if you leave it out, it's not going to affect your answer because you're squaring the bracket. And obviously, if you square something, whether it's positive or negative, it will come out to be positive in the end. So that's why I left it out. All right, so I hope that answers your question. Is there anything else there, Katleho?
Yes, they're to do with, let me check again. Okay, in minus x, the minus p4 minus 4, why don't you divide each term by minus 1 to remove the coefficient of x of the negative sign? And that's a question by Lisecha.
All right, that I'm not following because we didn't actually have a negative coefficient of the x squared.
Yeah. Okay, let me try read another one to you. Why do we simplify a root of 25, but earlier we did not do that for the root of 16 and p2 or squared, which is 4 and p?
All right. Okay. Now I'm glad that question was asked because everyone always makes that mistake. You actually, the reason we can't square root the numerator here, because remember, guys, you can never square root across a plus sign. Those are two separate terms. So you're not allowed to square root and say, okay, well, that's going to give me 4 plus p. That's absolutely not right. And I'm really glad that that was asked because that's a common mistake and that's a good question to ask. Because why can't we do this? Why can't we just square root? Think of if I was adding 16 plus 9, right? Say I had that underneath my square root sign. And I went, okay, well, I can square root 16, I'll get 4, and I can square root 9, and I'll get 3, and then my answer is 7, right? According to that logic. However, 16 plus 9 is actually 25. So the square root of 25 is 5, which is not the same as this 4 plus 3 answer, which is 7. So hopefully that shows you guys at home that you are not allowed to square root across a plus sign, and that's why we didn't square root when we had the p squared term, because you can't square root across terms. Okay, you can only square root an absolute square, okay, like for example 25, or you can square root if there's multiplication signs involved, but you cannot take the square root across two separate terms. All right, so I hope that answered your question, and I think it's time we get back to our next question for the evening, which is quite a long one, so it's going to take us quite a lot of time. Okay. All right. So guys, the question we're going to do is on functions, and remember this was a massive section. We covered it over quite a few weeks on the live show, and so if you have any questions on graphs and functions, this is the time to get them in, but I'm going to try and do a question that encompasses all the different problems that you could possibly have with this kind of graph question. All right. So they tell you the graphs of fx and gx are drawn, and these are not drawn to scale. And then they just tell you a little bit about the points. So those are two graphs, f and g. So g is your straight line. So this is g of x. And then f of x is the green graph, the parabola. Okay, so they've drawn those two graphs. They tell you that a and b are the x-intercepts, and c is the y-intercept of f of x. G is the turning point of the graph, so that's the turning point, those are your intercepts. And what else do they say? D is the y-intercept of the straight line. Use the sketch to answer the questions. Okay, typical test question this. All right, so you've got your two graphs. Let's analyze. They've given us the points. They say A and B are the x-intercepts of the parabola. C is the y-intercept. G is the turning point. They also tell you that D is the y-intercept of the straight line. So they say in the first question, just looking at those graphs and using those graphs to help you, determine the coordinates of A, B, C, and D. So remember, if we looked at the graphs, A, B, C, D, x-intercepts, y-intercept, and then that's D is the y-intercept of the straight line. So they're basically asking us to find the x and the y-intercepts of each of the graphs. All right, so let's quickly get going with that one. Okay, and this is question A, or solution A. Okay, and the two graphs that we've got, and I'm just going to write them down here. We've got f of x is equal to minus 2x squared minus 4x plus 30, and then g of x, this was 2x plus 10. All right. To find the x-intercepts of the parabola, remember that's where you let y be naught in the equation that defines the parabola, which is f of x. Woo, and that disappeared. Let's just call it back. All right, so we're going to find the x-intercept by letting y be naught. So for x-intercept, we say let f of x equal to naught. And this is to help us to find the coordinates of a and b. So therefore, I've got minus 2x squared minus 4x plus 30 is equal to naught. And then here's, I think one of the questions that one of the students said to us, why can't we divide through by the minus to make it negative, to make it easier? Now it will actually work, because if we divide through by the minus, we're going to get something that's simpler. Divide through by the minus 2, I get x squared plus 2x minus 15 is equal to naught. All right, and then we just factorize the trinomial, so we get x plus 5 times x minus 3 is equal to naught, so therefore x is either going to be equal to minus 5 or 3. what have we found, guys? Remember, if we go back to the graph, what we found are these points. We found point A and we found point B. So therefore the coordinates at point A, because remember they asked us to find the coordinates at point A, and remember always write it in coordinate form with an x and a y value. So A is -5 and 0, and then B we worked out as 3 and 0. Okay? Alright, so moving on, the next thing we had to find was C, which is the y-intercept of the parabola. Okay, our equation is -2x squared minus 4x plus 30. If I want to find the y-intercept, I say, let x equal 0. Alright, so therefore I'm going to get f of 0, because remember, wherever there's an x, I'm replacing it with 0. And I'll get, if I replace all of these with 0, I'll get f of 0 is 30. So therefore our y-intercept is 30. So C is the coordinate 0 and 30 on the parabola. Okay, so going back up to the graph, point C was 0 and 30. The next thing we had to find, which is the last part of question A, was we had to find D. And D, if you look at the graph, it's just the y-intercept of the straight line gx. So the equation here, remember, gx is equal to 2x plus 10. If I want to find the y-intercept, I just let x equal 0. So therefore, in g of 0, I'm going to get 2 times 0 plus 10, and I just get 10. So therefore, D is the point 0 and 10. All right. So the first question, usually when it's in a test and that, the first question is always nice and easy, eases you into everything. All of you should get full marks for that, as long as you don't make any careless mistakes. Okay, finding x and y intercepts, standard question. Okay, the next one's a little bit trickier. They say, hence write down for which values, hence means using what you've just worked out. Hence write down for which values of x, f of x, so we're talking here about the parabola, greater than 0, where's f of x positive? So they're asking you to use your graph and use your values that you've just found to see where the graph is positive. Now remember, your graph will be positive above the x-axis and it's negative below the y-axis. So where is my graph positive? Well, if you look at your parabola, the only time it's positive is between this value a and between that value b. Because at that point, if you were to look at any value above the points a and b, or between the points a and b of the parabola, they all lie above the x-axis. So therefore, we've only got positive y values. So therefore, x has to be between the points a and b. So how do we write it? We say, remember, we're just looking for it to be greater than 0, so just where it's positive. So therefore, x has to be greater than -5, which was our x-intercept at point B. At point A, sorry, and then less than 3, which is the x-intercept at point B. Okay, so as long as the graph is between those 2 points, it will always be positive. All right. Okay, guys, so we've done, second one's a little bit trickier. Just remember, if you're talking about positive values, where's a graph positive? They mean look above the x-axis. The one thing you need to remember here and to be careful of, if the question says just greater than, so in other words, there's no equal sign there, when you give your solution, you won't have equalities at the end of these less than and greater than signs. There will just be greater than and less than signs, no equal signs at the bottom of those. Okay, so it's not going to be equal to the point because we don't want the graph to be equal to 0. Okay, moving on to point C. Determine the coordinates of E, which is one of the points of intersection of the 2 graphs. All right, so if we look at point E, there we go. It's where the 2 graphs intersect. It's one of the points because the other time that they intersect is down here at point A. How do we find points of intersection? Remember, we do it over and over again. To find points of intersection, we have to solve simultaneously. Okay, so you solve the equation simultaneously to find the points of intersection of the graph. So let's get on with that. All right, and now we are on to part C. Okay, so we say the two graphs are equal to each other. This will help us to find the points of intersection. All right, and you've just got to be careful with your signs here, because once you know what to do, it becomes quite easy to do it, as long as you don't make careless mistakes. So we've got minus 2x squared minus 4x minus 2x. When I bring it over to the left-hand side, will become minus 6x plus 30 minus 10 would be 20. We can then divide through by the minus 2, so I'm going to get 2x squared plus 3x minus 10 is equal to 0. And then we can factorize that. Sorry, we've divided through by the 2, so that's bad of me. We shouldn't have a 2 there. We've got x squared plus 3x minus 10. Factorize that. So we get x plus 5 times x minus 2. So therefore, our answers here are going to be x is equal to minus 5 or 2. And therefore, if we look at the graph, the point we've got to choose is 2. Because remember, minus 5 was the x-intercept. So therefore, the only remaining point is here at E. So therefore, that point is going to be 2 and something. In order to find out what that something is, what we do is we take the 2 and we substitute it into either one of our equations. I'm going to put it into the straight line because it's the easier one. So g of 2, I'm going to get 2 times 2 plus 10, which is just going to give me 14. All right, so therefore E, remember, always write it as coordinates. E is the point 2 and 14. Okay, guys, and I'm going through this quite quickly simply because we did so much of work on functions. I know that I personally have done at least 2 sessions on the live show on functions, so we're going through it quite quickly. So if there's anything that you really don't understand, please send those questions through, but also it's just a matter of revising. Okay, so we've got part D, E, and F left. We've got to find D, which is determine the equation of the axis of symmetry. Remember, your axis of symmetry is the point that cuts your parabola exactly in two. So it's actually the x value of the turning point. All right, and how do we find axis of symmetry? We say x is equal to minus b over 2a. So straight from your equation, you're going to put in your values for b and a, and you're going to get x is equal to minus 4. Okay, remember to use your brackets here and your signs correctly. All over 2 times a, which is 2 times minus 2, so I'm going to get 4 over minus 4, which gives me minus 1. So therefore, my axis of symmetry is x is equal to minus 1, which means on this graph, remember they said at the beginning that g was the turning point, the x value at that coordinate would be minus 1. All right. Okay, the next question. Determine the length of GH if GH is parallel to the y-axis. So they're asking us for this length, GH. We know it's parallel to the y-axis. How do we find that length? Well, remember, whenever you want to find the length between any 2 points on the graph, it's always top graph minus bottom graph. So if I want to find the length of GH, it's going to be the top graph, which is the parabola, minus the straight line. That would give me the length. As simple as that. We also know that the x value at that point is minus 1, so all we would do is substitute that minus 1 into the equation. All right, so for GH, and I'm going to try and skip a lot of the working here, it's just going to be the parabola, which was minus 2x squared minus 4x plus 30 minus the equation of the straight line, which was 2x plus 10. You will then get an expression for for that. All right? And I want to find the length of GH, and I know that the x value at that point is -1. So all I would do is substitute -1 in place of x. All right, so after I've simplified all of this, substitute -1 in, and you will get an answer of 24. All right, so therefore the length of GH is 24. You can see I'm rushing through this because we are quickly running out of time and we don't want to take up the grade 12's time. I'm sure they'll be very upset. So GH, you get an answer of 24. Last question. If JL is equal to 60 units, then hopefully the grade 12s are also tuning in here because this is important for them as well. If JL is equal to 60 units, determine the length of OK. So if we go up to the graph, we see that JL is that entire distance between the straight line and the parabola. And like I said to you before, if you want to find the distance between 2 points, all you do is you say top graph minus bottom graph. Okay. That will give us the distance, and they tell us that that is 60. But they want to know what is the distance from O to K, which means they need the x value at this point K. All right, so what do we do? And again, I'm going to go through it quickly and just give you the basic steps so that you can do it at home. All right, so for JL, it's going to be the top graph, which is the straight line, which was 2x plus 10. Minus the parabola, which was minus 2x squared minus 4x plus 30. Okay, so that's going to give us an expression of, well, whatever the expression is. We're not going to have time to simplify all of it, but it's going to give us 2x squared, let's see, 2x plus 4x is 6x. And 10 minus 30 is minus 20. And all of this is equal to 60. Okay, so JL gives us this expression equal to 60. So therefore, we're basically going to solve, guys. 2x squared plus 6x minus 80 is equal to 0. And what you do is you solve for x there. You will end up with x is equal to minus 8 or 5. After you solve all of this, you get x is equal to minus 8 or 5. If we go back up to the graph, we see that we are definitely looking for a positive value. So therefore, x has to be 5. So therefore, the x coordinates at point K is 0 and 5. So therefore, the distance OK will be equal to 5 units. Okay, sure. And we did that just in time for the end of the show, I think. I don't know if I'll have time to answer any of your questions, but I hope that you all understood this section on revision. We went through so much of work, guys, so please revise before your exams.
Thank you, Natasha. Thank you, guys, for a fantastic show. Thank you to Liberty as well for sponsoring our fantastic show. You grade 11s were awesome. Grade 12s, remember that you're up next. See you next week, grade 11s. Bye.